Hello everyone, I am Vaishnavi from CSM third year. Today I will be presenting phase 2 of our secure file sharing system project, specifically focusing on user authentication and backend development. In this phase, we moved beyond the basic structure of our project and dived deep into the building a secure functional backend that can handle user data safely and efficiently. Here is a quick overview of what I will be covering today. We will look at the introduction and objective of this phase, then walk through the backend and authentication implementation, followed by the system components and development insights, and finally wrapped up with the phase 2 outcomes and conclusion. Introduction and objectives. So, what we were trying to achieve in phase 2, the core problem we are solving is this: any file sharing system is only as good as its security. If we can't verify who is accessing the system, we can't protect what they are accessing. Our main goal for this phase were: first, to develop a backend using Flask in Python; second, to implement a complete user registration and login system; third, to secure password using the hashing techniques so they never store in plain text; fourth is to generate JWT token for session management; and finally to connect the entire backend to the database. The expected outcome of all this is a fully functional, secure authentication system ready to support file operations in the next phase. Backend and authentication implementation. Let me talk about the technology choices we made. For the backend, we chose Python along with the Flask framework, built on a REST API architecture. Why Flask? Flask is lightweight and simple. It doesn't force you into a rigid structure, which makes it ideal when we need flexibility, especially for implementing our own security logic. It also very developer friendly and has great support for building RESTful APIs quickly. These qualities made it the perfect fit for a secure modular system like ours. User registration module. Now let's look at how user registration works. When a new user signs up, they provide three things: a user name, and email, and a password. The crucial step here is password hashing. Instead of storing the raw password, the system hashes it first before saving anything to the database. This means even if someone gains access to the database, they can't see the original password. This simply build powerful design decision prevents data leakage and forms the foundation of our security model. Password hashing mechanism. This brings us to password hashing. The mechanism is straightforward. When a password is entered, it is converted into a hashed format using a cryptographic algorithm. The original password is never stored. Not even the admin can see it. Why is this so important? Because if a database attack occurs, like a SQL injection or a breach, the attacker still can't retrieve the real passwords. It protects user from credential theft and significantly reduce the impact of any security incident. User login system. Moving to the login system, when a user tries to log in, they enter their email and password. The backend then takes that password, hashes it, and compares it against the stored hashed value. If the credentials match, a JWT token is generated and returned to the user. If they doesn't match, access is simply denied. This is the core of how authentication works: clean, secure, and stateless. JWT token implementation. JWT, JSON Web Tokens, are at the heart of our session management. Their purpose is threefold: to enable secure authentication, manage user sessions, and protect API endpoints. Here is how it works. When a user successfully logins, A unique JWT token is generated and sent back to them. Every time they try to access a protected route, they must include this token. The server validates the token and only then grants access. Importantly, the token also expires after a certain time, which limits the exposure if a token is ever compromised. Database integration. For our database, we chose PostgreSQL. It stores four key pieces of data per user: the user ID, email, hashed password, and role, either admin or user. Why PostgreSQL? Because it is reliable, secure, and well suited for the structured data like user records. It integrates smoothly with Flask and support the role-based structure we need for the future phase. System components and development insights. During phase 2, we developed three primary API endpoints. Post register handles new user sign-up. Post login handles authentication and token generation. Get protected route is an example of a secured endpoint that requires a valid JWT token to access. The last one is key where every sensitive operation in our system is behind a token check. No token, no access. Role based access preparation. We also laid the groundwork for role-based access control. In phase 2, we defined two roles, admin and user. These two roles are stored in the database and will be used in phase 3 to control what each user type can and cannot do in the system. These phase set up the structure. Phase 3 will enforce the rules. Testing tools and challenges. For testing, we used Postman. It allowed us to test all our API endpoints, verify login responses, check token generation, and validate error handling. Of course, development was not without its challenges. We faced password authentication errors, token validation issues, database connection problems, and difficulties with JWT expiration handling, but we addressed each of these by implementing proper hashing, writing middleware for token verification, and using Postman for step by step debugging. Each challenge taught us something that made the system stronger. Phase 2 outcomes and conclusion. To summarize phase 2, we successfully built a secure backend using Flask and PostgreSQL. Users can now register and log in securely. Passwords are protected through hashing and sessions are managed through JWT tokens. The role structure is in place, ready for the next phase. This authentication layer is the backbone of the entire file sharing system. Without it, nothing is secure. With it, we have a solid foundation to build file, upload, download, and sharing features in phase 3. Thank you.